Everyone, my name is Leo Wing, and today I'll prove the angle sum and difference identities for cosine. So let's look at the cosine of a minus b first. So let's say this angle is alpha and this is beta. So then this angle will be a minus b. Okay, so what is this point? This point is cosine of b, sine of b, right? Because this is based on b, and this will be cosine of a, sine of a. And then we can look here. So if we transform the a minus b to the x-axis, we can see that this is a minus b, so that will be cosine of a minus b, and that will be sine of a minus b. And this point will be 1, 0. So now let's see. This is the same, and this is a unit circle, right? So then this length must be equal. So, which means that d1 is equal to d2. So what is d1? d1 is square root of cosine a minus cosine b squared plus sine a minus sine b squared, and that will be equal to cosine of a minus b minus 1 squared plus sine of a minus b minus 0 squared. Okay, so now we can cancel out the square root. So then that will give us cosine squared a plus cosine squared b minus 2 times cosine a cosine b plus sine of squared a plus sine of squared b minus 2 sine of a sine of b, and that is equal to cosine of squared a plus b plus 1 minus 2 cosine a minus b, and plus sine of squared a minus b. Oh wait, and by the way, that should be a minus. Okay, so we can group these. And that would be 1, and this. No, sorry. This and this, that would be 1. And then this and this, that would be 1. Minus 2 times cosine of a cosine of b plus sine of a sine of b. So that is equal to, and these will be 1, and there's another 1 plus 1 minus 2 cosine of a minus b. So now these will cancel out, and this will cancel out. So we will get cosine of a minus b is equal to cosine of a cosine of b plus sine of a sine of b. And we can, through that, let's find cosine of a plus b. So that be equal to cosine of a cosine of negative b plus sine of a sine of negative b. So since cosine is an even function, cosine of negative b is equal to cosine of b, but sine of negative b will be equal to negative sine of b. Okay, so through these, we can find that cosine of a plus b is equal to cosine of a cosine of b minus sine of a sine of b. Okay, so that's good. So now we have proved these two. We are going to prove sine of a minus b and sine of a plus b. So we'll start with sine of a plus b. So we're trying to find sine of a plus b. So let's consider this. What is cosine of 90 degrees minus a minus b equal to? So well, there's two ways of representing this. We can represent it into cosine of 90 minus a and then minus b, or it can also be equal to 90 cosine of 90 minus a plus b. They're equivalent. But what is this equal to? Let's think about it for a minute. Yes, we know that cosine of 90 degrees minus theta is equal to sine of theta. So that is also, therefore, equal to sine of a plus b, which is what we're trying to figure out over here, right? Okay, so let's continue. So essentially, we're going to try to find sine of a plus b, right? And that's also equal to this, that we're trying to find cosine of 90 degrees minus a minus b. So what is that equal to? We have the formula up here. Wait a second. So we have it up here, which is that cosine A, cosine B, and sine A, sine B, right? Okay, so let's carefully write it down. So that is equal to cosine A, cosine B, plus sine A. Oh wait, sorry, I just figured out we're supposed to find. Oh wait, I'm right, sorry. Okay, so plus sine of A, sine of B. Okay, so what is that equal to? So we can just plug in the A, which is this, and the B, which is this. So that is equal to cosine of 90 degrees minus A, and then also cosine of B plus sine of 90 degrees minus A times sine of B. Okay, so we also have this up here, right? And it's important to point out another identity, which is sine of 90 degrees minus theta is also equal to cosine of theta, just like the previous formula up here. So now we can substitute the 1, and let's mark this as 2. And let's say this is 3. So we plug in 1 and 2 into 3. And we can find that this part will be equal to sine of theta. And then we'll keep the cosine of, sine of theta, so that will just be sine of A times cosine of B. and plus, and that part is equal to this, so that is cosine of theta times sine of b. Wait, that's weird. Okay. So the sine is not sine of theta. I mean, it is, but it's supposed to be sine of cosine of a. Right? Yep. Okay, so then that is equal to sine of a plus b. Okay, so now let's find the sine of a minus b, which is just, let's just plug in sine of a times cosine of negative b plus cosine of a times sine of negative b. So let's consider this. Cosine of negative b is equal to cosine of b, right? Because cosine is the even function. And for the sine of negative b is equal to negative of sine of b, because sine is the odd function. Okay, so now based on that, let's once again, so this is 4, 5, and let's say that is 6. So plugging 4, 5 into 6, and we will get sine of a minus b to be equal to sine of a cosine of b plus, oh wait, actually minus cosine of a sine of b. And we are all proven. Thank you for watching.